presenting a video in organic chemistry. Please subscribe to my YouTube channel by clicking on the bell icon to access more videos. So under organic chemistry, we are going to look at the homologous series. Homologous series is a family of related compounds that share common properties or characteristics. It is a family of related compounds that share common properties or characteristics. So, it's a family of compounds that are related in properties or characteristics. That is called homologous series. The word homo means the same, meaning it is a family of compounds that have the same properties or that share similar properties. Now, the following are members of homologous series. Number one, members of homologous series include alkanes. Alkanes are among the members of homologous series. Other homologous series are alkenes. Apart from alkenes, we have alcohols, also known as alkanols. Apart from that, we have carboxylic acids or alkanoic acids. Other homologous series including esters. Other homologous series including hamides, okay, aldehydes, ketones, and so on and so forth. Okay, but we are going to look at these homologous series: alkanes, alcohols or alkanols, carboxylic acids or alkanoic acids, esters, and the hamides. To begin with, let's try to look at the characteristics of homologous series. Characteristics of homologous series. Characteristics of homologous series or properties of homologous series is one and the same. One of the properties of homologous series is that they have similar chemical properties. They have similar chemical properties. They have similar, they have similar chemical properties. So they undergo similar chemical reactions. So what I mean is, let's try to consider the two compounds, propane and butane. Propane and butane, they belong to the same family, which is alkanes. Remember, alkanes, these compounds, their engine is ANE. So meaning, since these compounds belong to the same family, we expect them to undergo similar chemical properties or similar chemical reactions. So propane, both propane and butane undergo combustion to form carbon dioxide and water vapor. They undergo similar chemical properties because they are members of the same homologous series. However, they differ in physical properties. So, despite belonging to the same family, the members of the same family differ in physical properties, meaning they show different physical properties. They show a gradual variation in physical properties. Okay, such that meaning they differ in melting points, meaning they have different melting points even though they belong to the same family. They have different boiling points, they have different densities and different solubility, such that their melting and boiling points increases as the number of carbon atoms increases. For example, if you have a compound, let's say like these are compounds, we have these three compounds, then you are told to say which one among these compounds has the highest melting point and highest boiling point. Look for the compound which contains the highest number of carbon atoms. So of course it's this one. It contains how many carbon atoms? 5. This is 4, this is 3. So this one contains the highest number of carbon atoms. Since it contains the highest number of carbon atoms, this compound you expect it to have the highest melting point as well as highest melting point. Then the compound with the lowest or least number of carbon atoms contains as the lowest melting point as well as lowest boiling point. So the compound with the lowest melting point and lowest boiling point is the compound with the least number of carbon atoms, which is 3. Okay. Apart from that, they differ by CH2 unit. They differ by CH2 unit. What does it mean? For example, if the first compound is methane, this is methane. We need to make sure that each carbon atom contains 4 bonds. 1, 2, 3, 4. This is the first compound for methane. The second compound is ethane. It must contain 2 carbon atoms. Let's now try to fill up the number of the carbon atoms so that each carbon atom is surrounded by 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. So now, this is the first compound. The next compound is this one. Now let's try to look at the molecular formula. This is C, 1, 2, 3, 4, CH4. This is 1, 2, C2. How many hydrogen atoms? 1, 2, 3, 4, 5, 6. So now, let's try to look at the difference in the number of carbon atoms. From the first member to the second member, there is an addition of 1 carbon atom. Here we have 1 carbon atom, we have 2 carbon atoms. So 1 carbon atom has been added to come up with the molecular formula for the next member. From the first member to the next member, there is an addition of 2 hydrogen atoms, because 6 minus 4 is 2. So meaning, members of the same homologous series, they differ by CH2. They differ by CH2 from one member to the next. Apart from that, the other characteristic of homologous series is that they have the same general formula. They have the same general formula. They conform to the same general formula. They conform to the same what? General formula. For example, alkanes. The general formula for alkanes is CnH2n plus 2, where n is the number of carbon atoms. So this is the general formula for alkanes. The general formula for alkanes is CnH2n. The general formula for alkanols is CnH2n plus 1 OH. The general formula for carboxylic acids or alkanoic acids is CnH2n plus 1 COO. So members of the same homologous series, you expect them to have the same formula. The other characteristic of homologous series is that apart from having the same general formula is that they have the same functional group. They have the same functional group. They have the same functional group. So members of the same homologous series, you expect them to have the same one, to have the same functional group. For example, if I come up with the formula for this compound, let's say I have 2 compounds. This is the first compound, and the second compound is this one. So now, considering this compound and this compound, you are going to discover that they have the same functional group, meaning they belong to the same family because they share the same functional group. And this functional group that I have circled is the hydroxyl group. This functional group is associated with alkanols. It is associated with alkanols or alcohols. So this is the functional group for alcohols or alkanols. So maybe in case you come across these compounds, then you are being asked to say, to which family of homologous series do these compounds belong? You simply have to look at their functional group. So, of course, the functional group is that of hydroxyl group. So now, which family of homologous series is associated with the hydroxyl group? Of course, it's the alkanols or alcohols. But if you come across a compound being written this way, you come across a compound which is like this, then you are being asked the question to say, to which family of homologous series does this compound belong? You look at the functional group. This is the functional group. So this functional group that I have said, the name of this functional group is the carboxyl group. And this functional group belongs to alkaloic acids or carboxylic acids. So the homologous. Okay, thank you very much.